Welcome to my channel once again. In the previous video, we have discussed about Pythagorean triplets. How, we will check, we will see whether how it will try to prove Fermat's last theorem, actually Fermat's last theorem. So, yeah, so we had the formula for Pythagorean triplets, that is a plus b whole square minus a minus b whole square is equal to 4ab. Okay, so if a is a square, b is a square, so let us take a is equal to x square, b is equal to y square. So we have x square plus y square whole square minus x square minus y square whole square equal to 4x square y square, that is equal to 2xy whole square. So this is also kind of a Pythagorean triplets. So take any xy and then you square them, add them, subtract them, do this minus, and then you will get this. Okay, so next what we did in the previous video is that if FLT is true for x is actually greater than 2, sorry, x is greater than 1 basically, sorry. X is greater than 1, then we will try to prove whether we have this kind of equation for all even numbers. So what we have done is that we have written down, let us take general expression of integers, even integers, right? So you have this. Then we have rewritten as e c power x whole square minus a power x whole square is equal to b power x whole square. Now, this is a Pythagorean triplet. So c square, big C, right? So a square is equal to big B square. So that means that in the Pythagorean triplets, we should have c power x, a power x, and b power x. Okay? So here we have a general expression for Pythagorean triplets. So that means that we will try to see whether we will try to equivalent these two. Let us take is equal to c is equal to x square plus y square, a equal to x square minus y square, b equal to 2xy. Okay, so now what you can do is that what is c minus a? If at all you have c minus a equal to x square plus y square minus x square minus y square, that will be like 2y square. Okay, here big C is actually equal to c power x. So c power x minus a power x that means if I can find for any x c power x minus a power x is equal to 2y square, then I can actually find Pythagorean triplets in the higher power. Then we can actually see that, okay, FLT, we can find, let us take c power 4 minus a power 4 is equal to b power 4. We can find this. Or c power 6 minus a power 6 equal to b power 6. Okay, so this is the crux of this equation. If you can find for any x, this is true. If you find c is of course positive integer, a is positive integer, y is positive integer, then x is also kind of a even number. Then if you can find this, then actually we can find this. We can find this combination. Now let us see whether we can actually try to prove we can find this this equation if you can find Pythagorean triplets in this. Okay, I'm going to rub it off all this. Okay. For example, you take x is greater than 1, right? Let us try to find whether you have c square minus a square equal to 2 into y square. Okay. So, actually 2y is equal to b over x here. So, 2y square is actually b over x whole square. Okay, so in short, if you can find take any square, p square equal to 2q square, then actually you can find this. Now this is kind of a, we'll try to see whether we can actually find any PQ, and one of the squares into 2 times is square of the other. So this expression gives rise to, for example, you have p square is equal to 2 into q square. So that means that p square is even. That means that p is equal to 2p1. Then we have 4p1 square is equal to 2q square. 2p1 square is equal to q square. Then again q square is even. So ultimately we hit the rock bottom. So given a square, area of the square is actually square of the number. So given a square p, can you find exactly the 2 times square? Area 2 times. For example, this is p square. So this is 2q square. Can I find integers on the side of this? So the answer is no. You cannot find any of the positive integer square equal to 2 times of other square. Okay, there is a proof of, there is a proof for this. This is also gave rise to birth of the irrational numbers, that is root 2. Okay, but that is secondary. Right now we are focusing on whether we can find a square. Difference of any square is actually a square 2 times the other number. Okay, since this is not possible, something like, let us take c square minus a square is equal to something like 2y square that is like p square. So since this is not possible, so therefore you cannot find c power x minus a power x equal to 2y square if x equal to 2. Okay. I mean, the idea is that this should be a square also itself, because this should satisfy the Pythagorean triplets. So since that is so, we cannot find c power x we cannot find if x is greater than 1, sorry, if x equal to 2. Okay, so this is the proof of Fermat's last theorem for a power p plus b power p is equal to c power p. This is the proof for Fermat's last theorem c power 4. In the coming videos, what we will do is that we will try to see whether you can find, for example, 3. So c3 whole square minus a3 whole square equal to b3 whole square. Indirectly, you can find c cube minus a cube equal to 2y square. I mean, difference of two cubes gives rise to 2y square. So till then, have a great time. Thank you very much.